Hello and welcome to section 10.3. We are starting with the problem of the day, and I know a bunch of you are looking at this and freaking out thinking about having to do a proof. But really what I want you to do is I want you to identify means in which you could prove that these two triangles are congruent. So think about maybe what a diameter would be. Think about the center of a circle, how we name circles, intersecting lines, and come up with some reasoning for the problem of the day. We'll discuss it tomorrow. So we're going to learn a little bit about properties of circles, and we're going to start with this theorem. So in the same or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So what this means is that if you have two congruent arcs on a circle, A to B and C to D are congruent, they both have a measure of 65, then the chord A to B must be congruent to C to D. And working conversely, if A to B is congruent to C to D, so if these two chords are congruent as it's notated in the diagram, then these arcs are going to be congruent as well. And they're minor arcs, again, minor arcs are less than 180 degrees. That's what we have here, okay? The two circles shown are congruent, and the arc WX is congruent to YW. So these two arc measures are congruent. WX has an expression for a value, and YZ has an expression as well, and they want us to find the measure of WX. The measure of WX is going to be this line segment here because it doesn't have the arc sign, so it's considered a segment. The way we can solve this is we know if we have two congruent arcs, so we've got two congruent arcs, then the chords associated with those arcs are also congruent. So we can set them equal to each other. 7x minus 2 equals 5x plus 6. Subtract 5x, subtract 5x. I'm going to do this in one fell swoop. So I'm going to get 2x equals 8, x equals 4. They want me to find wx, so I'm going to substitute it into this expression. But we know it wouldn't matter which expression we substitute it into because they're congruent. So I get 28 minus 2, 26. So the answer would be wx equals 26. The distance from the center of a circle to a chord is the measure of the perpendicular segment from the center to the chord. So basically what they're saying is if they're asking you how far is segment AB, which is the chord, from the center of the circle, you would draw a line from the center of the circle to the midpoint of AB. So that would be how you would measure it. You'd always want to land on the midpoint of that chord. Now the perpendicular bisector of a chord passes through the center of the circle and is the diameter of the circle. So what they're saying is if you continued on, the measure from the center of the circle to the chord is going to land in the center of AB, in the midpoint, creating a right angle, and it's going to bisect the segment as well. So that means we have a perpendicular bisector. And if we continued on in the opposite direction, we would have a diameter for the circle as well. So the line that we've created from the center all the way to the side of the circle is a radius, and if we extended it the opposite way, it would become the diameter. And that's what essentially this is saying to us. If the radius is perpendicular to a chord, then it bisects the chord in the arc. So saying that if we're going to be measuring from the center point to the chord and continue through, that becomes the radius. And the radius becomes the perpendicular bisector when it goes through the chord. So what I know is that GE is going to bisect DF, and as a result, we're going to end up with bisected arcs as well. So we've got congruent segments and congruent arcs. In the circle G, the measure of D to F, so the measure of D all the way to F, is 150 degrees. They want to find D to E. And as we know, those two arc measures, if I were to break this in half, I would have the arc measure, let me get another color. I would have from D to E would be 50% of the total length. And then from E to F is the other 50%. So half of D to F is going to be 150. I'm hoping you did this in your head. 75 degrees. The arc measure of D to E equals 75 degrees. Okay, I actually think these problems are super fun because we're going to apply a lot of what we know in these problems. So in example number 1, the diameter is 68, so the measure here is 68. They want us to solve for x. X is the point from the center of the circle to where it lands on the chord. So what we want to use is a right triangle. They've already drawn a right triangle for us here. If I erase this, you can see it. So how do we get values to put on that right triangle? Well, I know that the diameter is 68. So that would mean the radius, which in this case is going to be my hypotenuse, is 34. I also know that from the midpoint of the chord, which is perpendicularly bisected, to one of the sides is 30, so the other side must be 30 as well. So now how would you find x in this situation? You have the Pythagorean theorem you could do, or maybe something special might come to mind. So go ahead and try working on that one. Pause the video, and we'll do the solution in class. Hopefully you pause the video because I'm moving on to the next one. All right, so where can you draw a right triangle? They're all pretty much going to end up being the same. I'm going to start from the center point and draw to the side of the circle, creating a radius. Now, if the midpoint to the side of the circle here is 15, then I know that this measure here is also going to be 15. I also know that if the radius is bisecting this chord and half of the chord is 12, the other half will be 12 as well. So now, what information can you use to determine the other leg of this right triangle? Because we know it's a right triangle because of the perpendicular bisector that has been drawn from the center of the circle to the side. This just might be another special one, so think about that. And lastly, the diameter for example, the third example, is 12. So if that's 12, then I know that this hypotenuse is going to be 12 as well, because this is the radius. So in this situation, they want us to find the measure of the chord. So how do we find the measure of the chord if we're only given one side of a triangle and an angle measure? Go ahead and use the tricks of the trade that we learned a few chapters back and solve for that as well. I will check in with you tomorrow. Thank you.